Okay, so in the last video, we talked about absolute value equations. So naturally, in this video, we're going to talk about absolute value inequalities. So I want to look at a couple of rules, and then I want to try to go through several examples here. So we can, if we have the absolute value of some number or expression A being less than B, this is equivalent to saying we have negative B is less than A, which is also less than B. So we're trying to find some interval that's going to satisfy, some single interval that's going to satisfy this particular inequality. Okay, this is the same thing for less than or equal to as well. It works the same for both. And then if we have the absolute value of a number or expression A being greater than B, this is equivalent to A being less than negative B, or A being greater than B. And again, it works the same way for less than or equal to and greater than or equal to. Okay, so let's take a look at an example here. Here we have 5 times the absolute value of y being greater than or equal to 40. So let's try and solve this like we would in the previous video. So we will go ahead and divide both sides by 5 because our goal is to isolate the absolute value by itself. So we can cancel the 5s here. And that's going to give us the absolute value of y is greater than or equal to 40 divided by 5, which is 8. Okay, so there's 2 ways of thinking about this. You can either memorize the rules here, and that's fine, but I would also encourage you to try to think about what's actually happening here. Okay, what we're saying here is we're looking for all values of y that are a distance of 8 or greater from 0. Okay, so from the rules we get that we have y is going to be less than or equal to negative 8, or y is greater than or equal to positive 8, and then we would go ahead and graph that. But again, what's being said here, though, is we're looking for all values of y such that the distance of y is greater than or equal to 8. So here we can go ahead and graph this. So we start at positive 8 here, and we're going to do a filled-in circle because of the less than or equal to, and the greater than or equal to. And we're going to shade everything to the right, and then we're going to go to the left-hand side, and then we're going to shade everything to the left. And that's how you would graph this. All right. You could also write this in interval notation as negative infinity to 8, and we're going to do a closed bracket here because we're including the point negative 8, and we're going to union this with the interval from 8 to infinity, where again we have a closed bracket here because we are including the point 8. And then as explained in the previous video, or previous videos before this one, we always use a parentheses around the infinities. Okay, now let's look at this next one. Here we have 3 times the absolute value of x is greater than or equal to 15. All right, so let's go ahead and divide both sides by 3 because we want to isolate the absolute value by itself. So we'll have the absolute value of x is greater than or equal to 5. Okay, so this is equivalent to saying x is less than or equal to negative 5, or x is greater than or equal to 5. So again, we're looking for all values of x whose distance is greater than 5 from 0. All right, so we would start at positive 5, and again, we're going to shade in the circle here, and we're going to shade everything to the right, and then we're going to go on the left at negative 5 and shade everything to the left. Okay, let's try this one. Here we have for u, I can do a better 4 here, for u, 4 times the absolute value of u is less than or equal to 24. So here we can go ahead and divide both sides by 4, like we did in the previous examples. And that's going to give us the absolute value of u is less than or equal to 6. Okay? So you can think of this as, using the rules, we can go ahead and say that this is equivalent to negative 6 is less than or equal to u is less than or equal to 6. That's fine. But you can also think of this as saying we're looking for all values of u whose distance is less than 6 from 0. So let's graph this interval, and we'll see what this looks like. So we could start at -6, and then we're going to go starting from -6 to +6. And again, we're gonna fill in these dots because we have less than or equal to here. Okay, and that's what that interval is going to look like. Okay, but again, this is all values of x whose distance is less than or equal to 6 from 0. All right, let's take a look at this one. Here we have the absolute value of v plus 12 is strictly less than 12. Okay, so let's go ahead and start by trying to isolate the absolute value of v. So let's take 12 away from both sides. And that's going to give us, well, these are both going to cancel. So we have the absolute value of v is strictly less than 0. Okay, so what does this mean? Well, what this is literally saying here is the absolute, okay, when we say the absolute value of v is strictly less than 0, what we're saying here is we're looking for all values of v whose distance from 0 is less than 0. So we're looking for all values of v whose distance from 0 is negative. So we would actually just go ahead and say no solution here. Okay, there's no actual solution. Fun question though. What if this had been what if we had added a less than or equal to sign here? Okay, so all this, and instead this had become the absolute value of v is less than or equal to 0. What would the answer be here? Well, that would mean we're considering all points of v whose distance from 0 is either 0 or is less than 0. So in this case, we could actually include the point 0 as well. And the reason we could include the point 0 is because of this less than or equal to. So sometimes the choice of less than or equal to or strictly less than is actually pretty important, okay? So really pay attention to that when trying to solve these problems, because sometimes there might be a curveball thrown in there. Okay, let's look at one more. Here we have the absolute value of x plus 4 is strictly greater than 6. Okay, so looking back up at our rules here, if we have absolute value of some expression a being greater than b, we can write this as an or expression. Okay, so we're looking for all values. We're looking for all values in the expression x plus 4 whose distance is greater. I guess we would phrase it differently. We're looking for all values of x that would make the expression x plus 4 have a greater distance than 6, okay, from 0. So let's write this out a little differently though. So here we have x plus 4. We want to be less than -6, or x plus 4 is greater than +6. So here what we can do is we can go ahead and solve each of these for x. So if we take 4 away from both sides on this one, we'll end up with x being less than -10. Okay, and then over here we can take 4 away, and we'll get x is greater than 2. Okay, so we're looking for x less than -10. Kind of ran out of room here, so we'll make another line. Okay, so if we want to shade this in on the graph, we could write this with an open circle here at -10, and then we'd shade everything off to the left because we're looking for everything less than that. And then we'd have an open circle at 2, and we go for everything to the right here. And if we wanted to write this in interval notation, we could write this as the interval from -infinity to -10. Okay, and we're not going to include the point -10 because we have a strictly less than sign here. So we're going to use an open parentheses here. So then we're going to union this with the interval from 2 to infinity. And again, we're going to have a parentheses here because we're not including the point 2. This is because we have a strictly greater than sign.